Hello everyone, today we are going to solve the third problem of AtCoder beginner contest 335, which is long tracking. So the problem is quite interesting to me, that's why I am giving some explanation related to the problem statement. So what is the problem statement? The problem statement is Takashi has created a game where the player controls a dragon on a coordinate plane. The dragon consists of n parts numbered 1 to n, with part 1 being called head. Now there are two types of operations. One is 1 comma c, that means move the head 1 in the direction c. So c could be either r, l, u or d, and 2p means find the coordinate of part p. Now p could be from 1 to n because the dragon consists of n parts. Now let me give you some example, then you will understand it better. Now for this example, let's take this example only. So the n is 5 years, so the dragon consists of 5 parts. So the first part, head of the dragon, is at 1. So 1 2 3 4 5, it is like that. Now the first operation is 2 comma 3, that means this is a type 2 operation, so we have to print the coordinate of the third part. The coordinate of the third part is 3 comma 0. Okay, so again one part which I missed is that the part, initially the part I is located at coordinate I comma 0. So initially the initial phase, the third part is at coordinate 3 comma 0, so answer will be 3 comma 0. Now the second operation is type 1 operation, so we are moving the first part by 1 uh, upwards. So the first part is moving upwards. Now I think all of you have played the snake game. So let's say the snake consists of 5 parts, 1 2 3 4 and 5. Now we are moving the first part towards up. Okay, so what will happen, the second part will come into the first part's place and the first part will go in the above, uh, in the upward direction. Third part will come to the second part place, fourth part will come to the third plus parts place, fifth part will come to fourth part place. So the updated snake will be like this, let's take some linear line. So the first part will be at this position, second part will be at this position, third part will be at this position, fourth part will be at this position, and fifth part will be on this position. So one thing you might have observed is that the last part of the snake moved to the left and the first part of the snake moved to upwards. Okay, so the let's now see the constants. Now the constants is n is 10 to the power 6 and the number of operations are 2 into 10 to the power 5. So if we don't think about the constant, the first solution that comes to our mind is that let's move each and every part. So let's maintain some coordinate map, you can say, or coordinate vector. So coordinate of I will determine the position of the ith part. So when we are doing some operation on the head, each and every part will move. So we will change the coordinate of I value for each and every part. So the overall time complexity for that operation will be this type of approach will be order of n into q. But here you can see that n is 10 to the power 6 and q is 10 to the power 5 around. So this approach is not obviously possible. So we have to solve the problem in something like order of n log n, or something like q log n, or something like that. Okay, or order of n plus q. So now one interesting thing that makes the problem beautiful is that uh, what is happening, you have to observe that what is happening when we are moving the head. So I have already told, when we are moving the head towards any direction, the second part will come to the first part's place. Like let's say uh, p1 determines the position of the head, p2 determines the position of the second part, similarly pn will determine the position of the nth part. Now let's say in P1 will determine the new position after moving head of head. Now similarly in P2, similarly in Pn, right? Now one interesting thing you can observe here is that when we are moving the head, P1 will be something like only P1 will change. Now P2 will change to what? Sorry, my bad. Now in P1 will be something new, so we will determine that in P1. Now in P2 will be what? In P2 will be P1. Similarly in P3 will be what? Now in P3 will be P2. and in Pn will be what? In Pn will be nothing but Pn minus 1. Okay, that's the most beautiful thing you have to observe. Now after that the problem becomes quite straightforward. Now we are just shifting everything, like we are just shifting P2 P3 like that. So let's say we have something like P1 P2 up to Pn. Now what we are doing, we are doing some left shift. After left shift operation it becomes P2 to Pn minus 1, and we are just adding some in P1 here. Okay, so how we can solve this problem? So we can solve this problem using some data structure called DQ, right? So we can use DQ here. So DQ, what does DQ do? DQ has two type of operation. We can just pop from the front, or we can just pop from the back. Similarly, we can push into the front and we can push into the back also. So what we will do, in every operation we will determine this np1. Determining np1 is quite easy. Like let's say we have some coordinate x comma y. Now if it is the string is u, then we just have to increment the y pointer. If it is down, then we have to just decrement the y pointer. Similarly, if it is right, we have to increment the x pointer, and similarly if it is left, and we have to decrement the x pointer. Now we have determined the new position. So what we will do, we'll just uh, now you can see that Pn is not used, right? Pn is not used, so we will just pop the back of the DQ. So first operation will be pop back, so pop back. Now the second operation will be, we are just pushing the new P1, so we are just push front the new P1, right? New P1. And this is for the first type of operation. And for the second type of operation, let's say we have some we have to print the position of x. We'll just get the dq dot get, or dq dot add. For C++ it is dq dot add. We have to just print dq dot add x. Okay, so the question is quite straightforward if you get this observation. So let's jump into the code now. The code is quite easy also. So initially we are pushing I comma 0 in the DQ, and if it is type 2 operation, we are just doing q dot at x minus 1, because x is one best indexing here. The question uses one best indexing and DQ uses zero best indexing. That's why we have to do q dot at x minus 1. Similarly, for the second type of, sorry, I think for the first type of operation, we are determining the n pos. So pos is q front. So if it is up, we are just doing this thing, right? We are just in changing the x and y pointer. X will determine pos 0. Pos 0 will be x, and pos 1 will be y. So I am not explaining this part. After that, we are doing two operations: pop back. Yeah, we are doing q dot pop back. Now we are pushing the in pos at the front. So I hope you get my explanation. I will also provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. Thank you.